Okay, hey boys and girls. So today we're going to be going over spiral day 1. The word spiral just means that we're going to take all of the units that we've learned so far and just kind of put them all together for a mixed review. Okay, if at any point in time you want to pause the video because you'd rather try a question on your own first and then watch how it's done after, I highly suggest that's how you kind of go about these next few days for these review videos, because again, you have learned everything. So now it's just more of you testing your own knowledge to see, what do you remember? What do you not remember? Are there little things that maybe you're still a little confused with? So when we come back to school, you can let us know and we can address those. Okay? All right. So if I look at number 1, it says that we have the expression x to the 4th minus 16. And they want to know what that's going to be equivalent to. As soon as I see the word equivalent, I know that I want to think of the word equal. So it's asking me if I take this guy, it's going to equal which one of these choices. Okay? When I'm first looking at this, I'm thinking, okay, well, if I'm breaking something down, that's referred to as factoring. So what type of factoring should I be thinking of? Well, I know there's a few types of factoring that we learned. There's GCF, which is the first type, but there is no GCF between these two terms. So then I'm going to think of maybe dots. So dots is difference of two squares. So I do have a difference of two perfect squares. This is a perfect square, 16. This is an even exponent, so it's also a perfect square. So I know that that's the type of factoring that I want to go with. So I'm just going to rewrite the problem on the side here, and then I'm going to do the opposite. Instead of squaring, I'm going to square root. All right, so I know x to the 4th changes to x to the 2nd. Square root of 16 is positive and negative 4. So that's how I get these two double bubbles of x squared plus 4 and x squared minus 4. And if I look back at my choices, I can see that that's going to be choice 3. So now I'm done. If you have the Calculator X app on your phone, you could also type this into y equal, and then underneath you can type in choice 3 for y2. And if you check the tables, they should match. Okay, unfortunately, I don't have a calculator at home with me, but that's just another way. I just wanted to let you know that you could always check your answer. Okay, number 2, an expression of the 5th degree, so we have the 5th degree, is written with a leading coefficient. Leading coefficient is the number in front, and they're telling me that the leading coefficient is 7. And then it says that we also have a constant. A constant is a number with no variable. And I know that my constant is 6. And then it's asking which expression is representing this condition. All right, so if I look, 5th degree means that 5 is the largest exponent in the problem. So x to the 5th is biggest, maybe it's 1. X to the 6th, that's too big, so it's not 2. X to the 7th, too big, it's not 3. X to the 5th, okay, maybe it's 4. So if I keep reading, it says the leading coefficient, which is the number in front, is supposed to be 7. So I can see the number in front here is 6. The number in front here is 7. So I know it has to be choice 4. And if I check that last step, it says the constant is 6. So 6 is a number here with no variable, so I know that 6 was the constant. Okay, number 3. It says the Celluloid Cinema sold 150 tickets to 150 tickets to a movie. So we have 150, and that is representing tickets. Some of the tickets were child tickets, and some of them were adult tickets. All right, so as I keep reading, it tells me that a child's ticket is going to cost $7.75. So if I look back in all of my choices here, because since it's multiple choice, that's really nice. I know that one of these guys is the answer. I just have to figure out which one. So a child's ticket, it looks like they're using the variable C for that. And then it looks like A they're using for adult. All right. So if I know that a child's ticket is $7.75, I'm just going to look at all of my values of C and check what's going to match. So I have $7.75 for C, $70.75 for C, 10, right away that's not it, and again 10, so it's not going to be it. So just from this one section, I know it has to be choices 1 or 2. I'm going to keep reading. An adult ticket is $10.25. So an adult ticket, $10.25, adult, $10.25. So far, it's still 1 or 2. And then it says that if the cinema sold $1,470, and this is what's going to determine what the final answer is. So I can see that all 3 of these numbers are money. So that means all 3 should be in the same equation. If I take this money and I add it with this money, it should equal this entire amount of money. If I look at choice 2, they have my money numbers with 150. And I know that's not right because this is the number I should have had. Money, 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 money. So it has to be choice 1, just from, again, like trial and error here, just checking off what makes sense and what doesn't. So it can't be 2. Because I know 150 was tickets. So I know when I take all the adults and all of the children together, that should make the number 150. So I know that, again, this equation makes sense along with the second equation as well. Number 4, the tables below show the values of 4 different functions for given values of x. So I can see that I have the function f of x, g of x, h of x, and k of x. And it's asking me which one of these represents a linear function. I'm just going to box this because I know we had gone over this recently, actually, just last week. So I know if something is linear, I know that it means I should be looking for addition or subtraction between the y values. Okay, so if I look at the first table, how do I get from 12 to 19? Well, I'd have to add 7. So far I'm using addition. It looks like maybe that's the answer. I got to keep checking it though. How do I get from 19 to 26? Well, I have to add 7 again. Okay, still looks like it's the answer, but I have to check them all. How do I get from 26 to 33? Okay, I have to add 7 and I'm done. It just so happens that f of x was the answer because, again, it's adding each time with the same number. Okay, even if I was subtracting each time, it would have to be with the same number, and that could have been an answer, but it was addition. All right. Number 5. Let me just make sure I'm lined up here. All right. Number 5 says when I have that inequality, because I know this is an inequality symbol, when I solve it for x, it's asking what's the solution. So I know that solution is a really important vocab word. It's really asking me what's the answer. So if I want to solve for this, I'm going to start off by just rewriting that problem on the side. So we have 3x plus 2 is less than or equal to 5 times x minus 4. That's what all those symbols represent. So whenever I'm solving, I know the first thing we always teach you guys is to draw your train tracks. And then I just have to start simplifying. So whenever I see parentheses, I know that means I have to multiply, and I want to get rid of those parentheses first. So I have to look at the number in front, which is 5. So I'm going to distribute 5 to everything inside those parentheses. So right now this 3x plus 2 is just going to come down. And on the right-hand side, I'm going to distribute. 5 times x is 5x. 5 times negative 4 is negative 20. And now it's easier for me to solve because those parentheses are gone. I just have to combine like terms. So I'm going to start by, moving that positive 2 to the right-hand side. Okay, I'm going to move it over. So I know a positive 2 becomes a negative 2. I'm doing the opposite. Notice how I'm lining up and I'm organizing my work. These are like terms, and these are also like terms. So now I'm going to bring down my 3x. I'm going to extend my train tracks. I'm going to bring down my 5x. And then negative 20 minus 2 is negative 22. So if I have my numbers on the right-hand side, that means I want my variables on the left-hand side. So this positive 5x is going to become a negative 5x. I'm going to move that over. Again, I'm combining my like terms. So I know that these cancel. Now I have negative 22 left over. I bring it down. And 3 minus 5 is negative 2. So I have negative 2x. And then last but not least, I want to get x by itself. So the opposite of multiplication is division. So I'm going to divide negative 2 on both sides. And I get x with positive 11. Now the only rule you have to remember is when you have an inequality, you're going to flip it if you divide or multiply by a negative. Did we divide by a negative here? Yes. So is my inequality going to flip? Yes. So now it will become x is greater than or equal to 11. Okay, and that should have been choice 4. Number 6 says I want to take this expression, this whole big thing, and I want to see what it's going to equal. So just like from the first page, equivalent means I want to find what will equal this problem. So I'm going to do the same thing that I did on number 5. I'm going to just rewrite this formula on the side here. So we have 3 parentheses, x squared minus 1 minus x squared minus 7x plus 10. Okay, I'm just going to draw like a little line here to separate the questions. Just like number 5, whenever I see parentheses, I know that means to distribute or to multiply. So I'm going to take the 3 in front and distribute it to the x squared and the negative 1. And I'm going to take this coefficient out front, which is really a negative 1. Even though I can't see it, I know it's really there. Okay, so I'm going to take that negative 1 and distribute it to everything inside as well. So I know that 3 times x squared is 3x squared. 3 times negative 1 is negative 3. Negative 1 times x squared is negative x squared. Negative 1 times negative 7x is positive 7x. Negative 1 times 10 is negative 10. And we're almost done. Now I have to go back and just identify what's my like terms so I can simplify this, because right now it's pretty busy. There's a lot going on here. So I can see that I have an x squared on this term. I also have an x squared on this term. So here my coefficient is positive 3. Here my coefficient is negative 1. So 3 minus 1 is 2. So I'm looking for 2x squared, which right now all of them have, so that didn't really help me. So we have a 2x squared so far. Then I'm going to keep searching. Okay, this has just an x. And it doesn't pair with anything. There's nothing else there. So now I'm looking for 2x squared plus 7x. 2x squared minus 7x, gone. 2x squared plus, okay, 7x, that's good. 2x squared minus, that's bad. And then 2x squared plus, that's good. So it's 2 or 4. And then I'm going to just finish it up here to get the final answer. So I know that negative 3 minus 10 is negative 13. So if I look back, choice 2 has that negative 13 on the end. So number 6 was choice 2. Number 7, what is the solution? I'm going to highlight solution. Just like number 5, I know another word for solution is the answer. Okay. For something like number 7, I would really use the graphing calculator for this, just because it's so much faster to check for what's the answer, because it's multiple choice. All right, so if this was, something that we had our graphing calculator for, I'm going to just tell you right now that the answer is choice 3. But I know it's choice 3 because I know that when I plug in 2 for x, this equation is true. And if I plug in negative 6 for x, again, this equation is true. So I'm just going to set that up. Let me do it maybe right here. I'm trying to see where I have some room. So I'm going to write 2 parentheses, and instead of writing x, I'm going to use positive 2. So it's really 2 plus 2 squared minus 4. And when I type this whole thing just into the regular screen on my calculator, just, that blank screen at the beginning, when I type this in, I should be getting the number 28. And since it equals on both sides, I know that's an answer. Then I'm going to do it again, only now I'm going to do 2 times, not x plus 2, but negative 6 plus 2. Squared minus 4. And again, that should also be equaling 28. So again, if you were to type this into your calculator on the regular screen, you should be getting the number 28. So since again, it's equal on both sides, I know that both of these answers would have been true for number 7. Okay. Number 8, the zeros. Who can remember more vocab words that we can use instead of just the zeros? I think I hear it. Instead of zeros, we could say solution. Good. Instead of solution, we could also say the x-intercept. Excellent. Oh, that was it. Or we could say roots. So I know all of those words are represented by just that one word, zeros. So I'm really, again, just looking for what's going to be, oh my gosh, just threw a pen. What's going to be the answer? All right. So if I look at number 8, I'm hoping that a lot of you can identify this right off the bat as being a trinomial, because tri means 3, and I have 3 terms here. So this is another one. It's just like 7. It's so nice when they make these multiple choice because they're giving you the answer. You just have to determine which one is the correct answer. So again, I'm just going to kind of tell you it's going to be choice 1. But again, it's choice 1 because when I plug in, I'm getting the right solution that I need. So if I'm looking for the zeros, the first thing I'm going to do is take this equation and rewrite it. Instead of f of x, I'm going to write y equals. So it's really y equals x squared minus 5x minus 6. Okay? And if they're asking for the zeros, they want to know when is y going to be 0. Because you're always solving for x. All of these solutions are x values. So if I'm looking for an actual value for x, that's when my y is going to be 0. Okay, so I'm just going to rewrite this as 0 equals x squared minus 5x minus 6. All right, this is really the equation that I'm trying to solve. You can either try to factor this using that ABC factoring. That's totally fine. Or like I said, you could try to just plug in and get your answer from there. So anytime I'm replacing a variable with a number, we always want to use parentheses. So it's 0 equals x squared minus 5x minus 6. Only now I'm saying that x is negative 1. All right. If I type this whole thing into my calculator at one time, I should be getting the number 0. And since that works, I know that negative 1 is a solution. And it just so happens that negative 1 is only located in choice 1. So if negative 1 works, 6 better work, or something's going wrong. So I'm just going to do it again. So now 0 equals x squared minus 5x minus 6. And then again, I'm going to let x be the value 6 now. So it's 6 squared minus 5 times 6 minus 6. And when I type this whole thing in, you should be getting 0. So again, let me do it over here. Since 0 equals 0, I know I'm good to go. Choice 1 was the answer. Okay, if these didn't work, then I would have just said 1 isn't it, and then I would have tried 2 instead. Okay? And then number 9, it says, which equation, n-ordered pair, represent the correct vertex form and the correct vertex for that equation? Okay. There's a lot of key words here that I'm going to go over. So it says which equation, an ordered pair. So an equation has an equal sign, which all of these do, and an ordered pair would be these examples on the side. All of these would be considered ordered pairs, like an XY point. And I'm looking for the correct vertex form. So I know all of these equations are written in vertex form. And then I'm also looking for the correct vertex. And all of that information comes from this one equation right here. Okay. The best bet would be for you to type this function into the graphing calculator and look at the XY table. So in y equals, I would type in x squared minus 12x plus 7, and then I would look at the XY table. Since this is x squared and 2 is my largest exponent, I know that this is representing a quadratic or a parabola. They mean the same thing. That's the function that looks like a U, or like a happy face or a frowny face. So whenever I have an x squared, I want to look for that balance in my table. So I'm going to start with the x value 4, and I'm going to end with the x value 8. So we have 4, 5, 6, 7, 8. So when x is 4, my y value is negative 25. When x is 5, my y value was negative 28. At 6, it was negative 29. And then it kind of goes from there. We have negative 28 again, and then negative 25. So I know we go over this a lot in class. We're looking for that balance because that value that stands on its own right in the middle is the vertex. That's my turning point. Because if you look at the table, that's literally where it's starting to turn. I'm getting smaller and smaller, and then I go back up, and I go up again, and it kind of moves from there. So I know this is going to be my vertex. So positive 6, negative 29 is my vertex. This is the only choice that has it, so I know that choice 3 had to have been my final answer for number 9. All right. Like I said, a lot of these questions could have been done on the calculator, but just like me, I don't have one here at home. If you do have one, I suggest you really go back and maybe try to use it to get some of these solutions. But if you don't, this is mathematically how you would have gotten all these answers. All right, great job, guys. Have a great day.